Okay, guys, just welcome to this lecture, which is going to be on pointers actually mainly. But before coming into pointers, I want to just clarify a few doubts that you have asked in the previous videos I have come across. And the first one is I think a lot of people have asked me to go with Pascal triangle. You want the pyramid shape. And what I will do is I will just explain you again, once again Pascal triangle, and I will just transform the same Pascal triangle to the pyramid-like pattern. See, actually, on that day, I showed you this Pascal triangle, which is left justified. But you were asking me to tell me about this pyramid-shaped Pascal triangle. And first of all, I will just explain you this again, and I will implement the code for this one, and we will convert the same code into this pyramid-shaped Pascal triangle. Fine. So I have already have given you a formula. C is equal to C multiplied by I minus J divided by J. What is C? C is coefficient, and that coefficient will start from 1. I told you already. Okay, so what I will do is, first of all, I'll just explain you. For the first row, how many numbers are being printed? One number. In the second row, how many numbers? Two numbers are there. In third row, three numbers. In fourth row, four numbers. In fifth row, five numbers. So in ith row, if this 1 2 3 4 5 can be generally taken as I, and I can say that each and every row is having I numbers. So I calculation we have to do in every line. So what I will do is, first of all, I'll just take C is equal to 1, and this is called as I. Row index is called as I, and the column index is called as J. So this is what the I and J referred by this formula. And what I will do first of all is, initially I will just start from the first cell called 1 comma 1. And in this cell, what I will do is, before proceeding anything, I told always C will start from 1. So always take that the first number is going to be 1. Okay, so since your initial value of C is 1, the first row first value, when I am in 1 comma 1, what I will do, first of all, I will just print the value 1. Okay, I'll just print the value 1. So when my C value is 1, I print the value as 1. And then what happens? Only one number is required in the first row. So once one number is calculated, I will not go for any calculation. I will not go for any calculation. So I will suddenly go to the next row. For the next row, again C I will start from 1. For the second row, I will start my C again from 1. So when I am in 2 comma 1, what will happen? First of all, I will print the current C value, and then I will move. I will not, before moving to the next cell. See, I am now in 2 comma 1. First of all, I print the value 1. Then before moving from this cell to this cell, I will have to update. I have to update my C value. How I'm going to update? Using this formula. So now if you see, I am here in this red color marked cell, and this red color marked cell is having I value 2 and J value 1. So what I can do actually, C multiplied, what is the present C value? 1. 1 multiplied by what is I value? I value is 2. What is J value? J value is 1. So I value is 2, J value is 1. And it is whole divided by, what is the J value actually? What is the J value? The J value is also 1. So what is this calculation telling me? According to the precedence, first of all, bracket will be executed first. So 2 minus 1 is 1. So this is converted to 1. Next, the multiplication will happen due to the left to right associativity. So 1 multiplied by 1 will be again 1. Then 1 divided by 1 will give you 1. So the updated C value is also 1. When the updated C value is also 1, what I have to do? After updating the C value again to 1, I will move to this cell. I will move to the next cell. And after moving to the next cell, what I will do? I will print the current value of C. What is the current value of C? It is 1. So after printing the current value of C, then I think this line have only 2 numbers. So once this row have 2 numbers, after calculating these 2 numbers, I will go to the next row. In the next row, how many numbers have to be calculated? 3 numbers. So first of all, what I have to do? I have to start my C from 1. And first of all I just have to print my C value, and then only I need to go for next updation. What is the next, what is the current cell we are standing? We are standing in this 3,1 cell. We are standing in 3,1. So I value is 3, J value is 1. So what is the present C value here? Present C value is 1. So 1 multiplied by, what is I value? 3. What is J value? 1. So 3 minus 1 divided by, what is J value? 1. So first of all, the initial calculation is going to be 3 minus 1. So it becomes 2. So 1 multiplied by 2 will become 2. 2 divided by 1 is going to be 2. So my C value is updated to actually 2. My new C value is 2. So after updating the value of C, then I will move from this cell to this cell. So now I am standing in the cell 3, 2. And after entering into the cell 3, 2, what I have to do? First of all, I have to print the current value of C, and then I need to update the value. How to update the value? Again, the same scenario. What is the present value of C? The present value of C is 2. So 2 multiplied by, what is the present value of I? I is equal to 3. What is the present value of J? It is 2. So 3 minus 2 divided by, what is the value of J? 2. So first of all, 3 minus 2 will be executed. 3 minus 2 is 1. Then 1 multiplied by 2 will be equal to 2. Then 2 divided by 2 will be equal to 1. 2 divided by 2 will be equal to 1. So my new updated C value becomes 1. So what I have to do? I have to move, after updating, I have to move to the next cell, which is called as 3, 3. And after moving to this place only, I will be printing the new updated C value 1. So what is the work? What is it happening? First of all, I need to print C, then only I'm doing the updation. Printing C, updation. After updating, I'm moving to the next cell. So first print C, update the value of C, then move to the next cell, print C, update the value of C, go to next cell, keep on doing it. This is what already I have taught you how this is happening. Okay, so first of all, we'll write a code for this scenario actually. So coming to this scenario, first of all, I need to know what is the n value. N value is, for example, 5 here, 5 rows of data. And since we are going to write a nested loop, so I comma j will be here. So for I is equal to 1, I am starting, and totally n 5 rows. So n I is less than or equal to 5, which means n. Then I is incremented by 1. So now I have to write a loop for j equal to 1, and tell me one thing. This 1 to n is pointing towards a row. It is pointing to the row here. When 1 to 5 is pointing to the row, if you come to j, I think these places are need not to be traversed. These places need not to be traversed. So what you can say here, I can come up to j, because I told you in first row only one element is we are having. In second row 2 elements, third row 3 elements, fourth row 4 elements, fifth row 5 elements. So we are having only I elements. So up to ith index, if it is 1, come up to only 1th column. If it is true, traverse up to only second column. If it is 3, I value is 3, then traverse up to third column. If your I value is 4, then traverse up to 4th column. If your I value is 5, traverse up to 5th column. So whatever is your I value, that has to be the end limit of your j also. So what I can say is that I can write j is less than or equal to I. So j can stop at exactly the ith position. So j is incremented. So now what I can say is that before starting any row, I told you that the coefficient will be starting with 1. So take a variable called c. Declare a variable called c, and before starting any line, before starting any row, whenever a row started, we are taking our c value 1 and we are starting, right? So that is why I'm declaring c equal to 1 here. So now what I told you is that first of all we need to print C value. If you see here, first of all we need to print C value, then only updation we were doing. So first of all, what you have to do? First of all we have to do print %d comma c. First of all we have to do this, and then only updation. What is the updation? Updation is c is equal to c multiplied by I minus j divided by j. This is what the updation is all about. And after every row is printed, a new line has to be given. So after a row is over, I'm just printing a new line character. So how the flow is actually, okay, so first of all this line will be executed, then you enter this body process, and then this complete part is executed. When complete part is executed, then you come again to this print line, then only you will be sent back to the outer I loop. The flow will be like this. Okay, I'll just show you the background process also. Okay, so now we will just go with the implementation also. I'll just go with the printing process. Okay, so is it printing right? 111 121 1331 14641. So this is the left shifted one, the left justified one. But if you want to go for the center processed one, two things I can observe. What it is there is a in between space in between all the variable, all the numbers. There is spaces in between all the numbers. And one more thing is we are having some trailing spaces. I'm telling you again and again, whenever in a pattern leading spaces are coming, if it means that if the spaces are at the end of the pattern, then it is not going to affect us. But if the spaces are at the front side, then we have to do it. Okay, so how many spaces are here? In the first line 4 spaces, first line 4 spaces, in the second line 3 spaces, in the next line if you see 2 spaces, this line it is 1 space, and in this line it is 0 space. So how can I define it? Okay, so if the total number of rows is 5, then may I tell that it is 5 minus the row number? 5 minus 1 is 2, 4. 5 minus 2 is 3. 5 minus 3 is equal to 2. 5 minus 4 is equal to 1. 5 minus 5 is equal to 0. So may I say that it is n minus i? N minus i. Okay, n is 5 and I is this row. So that much space has to be printed for every row. N minus i space has to be printed for every row. So what that I can do is, first of all, before starting to print the numbers, I need to print that many spaces. How many spaces? So a third loop I will be using here. Okay, so for, see, when the loop is one inside the other, this j loop is inside I, so I cannot again use j. Sorry, again I cannot use I back. But this for loop and this for loop, this j for loop and this for loop is actually a separate loop. It is not one inside the other. So you can use the same variable again. So j is equal to 1 and j is less than or equal to n minus I. What this will do exactly? N minus I times this loop will run. So why I'm writing this loop? So because I want to print exactly n minus spaces I need to print. So when I want to print n minus spaces, what I can do is I'm running a n minus I loop and we are going to print spaces. We're going to print spaces. Okay, fine. So is there anything else that we left? Yes, one more thing is there. Now we have covered the space part, but one more thing is that we need to print these spaces which is in between, so what we can do is that instead of printing here the number, you can give one more space here. So when you give a space after this, automatically these spaces will be automatically given there, these spaces. After printing a number, one space. After printing a number, one space. After printing a number, one space. So in this format, if you print, you will be getting spaces like this. Okay. So now after, see, what is the two changes I have done? One change is this introduction of this loop. What is this loop for? For printing the trailing spaces. For printing the trailing spaces. These spaces. And what is the one more change? After this %d, I have added one space. What for this spaces for? What for the spaces? These spaces, in between spaces. For that spaces I have added space after %d. So now let us check whether this is working or not. Yes, you get the pyramid shape, right? You get the pyramid pattern for the Pascal. So this is what you were asking for, right? So hope it is clear for you, and any doubts you can post me again, so I will be clarifying your doubts in the next session. Okay, fine. So one more doubt was asked by the students about a nested structure, about how can we go with nested structure or not, nested structure or not. See, it will be very nice if you clear this nested structure here, but one thing I'll tell you, we are not handling structure here. I told you very clearly that I'm going to teach you only the basics of array and the basics of structure, that's it. Okay, we have a separate section for arrays and we have a separate section for structure. There I will be teaching you all the nested structure. So if I teach you here, what will happen is the flow will collapse here itself. So I'm noting down that you want to clear, I want to clear you nested structure, so which I will clear you in the part of structure. So now we are not going to touch nested structure, because for the things that we are going to see now, we don't require nested structure. Okay, fine. So what we will do is that I'll just suddenly get to the introduction of pointers. We will see pointers, and in the later section of structure we will see about nested structure, and we will go further. Okay, so I'll just go with pointers. So the next main concept that we will be seeing is pointers. What is a pointer? A pointer is a address variable. What is a pointer? A pointer is a address variable which is used for storing the address of a data variable. I'll tell you what is data variable. Okay, so it is used for storing the address of a data variable for indirectly accessing the data, Okay, I'll just explain you what I mean by saying like this. So pointer is a variable, address variable, which is used for storing the address of a data variable for indirectly accessing the data. This indirect access we will see later, but I'll just first of all show you what is pointer actually. Okay, so what I'll show you is that for example, a pointer is also a memory block. A pointer is also a memory block like this. Okay, a pointer is also a memory block like this, but a pointer is also like a normal variable only. It also will have some address. For example, let me take 2304. This is also having a random address like this. Okay, so what is the difference between a normal variable like data variable? I was saying that it will store the address of a data variable, right? So what is a data variable? A data variable is a normal variable which stores only data, which is capable of storing only data. You cannot store anything more than that. Okay, just I'll show you now. Wait. Okay, so this is, let me take it that this is an address variable and this is going to be a data variable. And this also, for example, let me consider that this is having, so what I will do is I'll just add one thing 0x, because I told you that always address is going to be a hexadecimal value, so I'm just taking it as a hexadecimal value. It is actually 16 digit hexadecimal, but I'm just, for better understanding, I'm just taking 4 digit only, right? Similarly, this block also will be having a random address, for example 3223. So both are like same, the structure is same, right? One block, and that block is having an address, and this here also there exists a block which is having an address. But what is the main difference? Now if you see data can be stored with any value called like 10, or if it is a character character variable, then single quote a means a is not stored, 65 number only it is stored, or a float number called 65.67. Similarly, a data like this is stored. So if data is stored in a block, and if it is defined by a variable, called x, then this variable is called as data variable. Suppose what is the work of address? What is the work of address variable? Work of address variable is store the address of a data variable. What is the address of this data variable? 0x3223, and you can take the address of this variable and you can store it in the inside part. can store it in the you are storing this data value, right? So you can store it inside the block actually. So here what happens, here data is stored inside, and here what happens, here the address of this data variable is stored here. For what reason I need to store? For what reason? Many people say that to store the address and to point to this memory location we are using this pointer. That is just the usage of pointer. That is not the reason why we need pointer. The reason why we need pointer, that we will see now. So I'll just tell you what we have two kind of variable. One is data variable, the other one is address variable. Data variable is capable of storing only values, but address variable is having the extra power. It's having a power to store the address of a variable, which a normal data variable cannot be able to store. Okay, so now I'll just tell you what are the other things that we will be seeing now. So the very first thing that we will be seeing is, we'll be covering is Y pointers. The next thing that we will be covering is declaration of pointers, how to declare a pointer. Next, followed by initialization, how to initialize a value to a pointer. Then I'll just show you what is dereferencing and referencing to. Okay, and then finally we will see about dynamic memory allocation. Okay, so first of all we'll come to the point why pointer is required. So clearly I said that pointer means storing the address of a variable. Now I have to clarify one thing, why I need to store the address of a variable. Because using this variable x, I will be directly able to access this value 65. But now what we are doing is, we are storing the address of this variable, and we are indirectly accessing this block. So we are indirectly accessing this value. So instead of indirectly accessing this value, why can't I directly access this value by y? Instead of taking an address variable called y and indirectly accessing to this value called 65, using x I can directly access, right? Which will be faster than this. Okay, so I'll just show you the reason why a pointer is required. For example, I'll show you the block main memory. Actually, I have yesterday itself I showed you this. So if you see here, so far I told you that the activation area will be created for every function inside this stack. And inside this code section, the compiled code will be stored here. .exe code will be stored here, program file. And still now we have not stored anything in the heap. Am I right or wrong? I have showed you that activation area is created inside stack, and the block are created here, allocated here. Memory blocks are allocated here. And here the code of any program will be stored. And what for heap is? Still now I have not spoken about heap, right? I told you that heap is a hard disk. So I told you one thing, that if a program is there, for example, I can just show you a few things. For example, if Mozilla Firefox is here, this application is in closed state. So if this application is in closed state, then I told you that whenever application is closed state, then it is in the hard disk. But whenever you are opening this file, and this file will be copied to RAM, and it will be open in RAM. So whenever a file is in closed state, it is in hard disk. Whenever a file is in open state, then it is in RAM. Okay, fine. So now what I will tell you is that if some data is there in the RAM part, then we will be able to easily access it. We will be able to directly access it. Okay, because our program is running on the RAM only. Because our program is executing means it is opening. Whenever our program is open, the program will be here in the stack section, here in the RAM section. Okay, so whatever data is there in the RAM, our program will be able to access it, but our program will not be able to access heap, because it is external to RAM. It is not inside RAM. It is a separate memory. So if I want to access something from this heap memory, which is hard disk, I will not be able to directly access it here in the RAM. I can show you, I can tell you one scenario, one example. You have a house, and inside the house you have two rooms. Okay, you have two rooms. Can you able to imagine two rooms? And one room is this complete code section and stack, which is called as RAM, and the other room is what called as this hard disk. Okay, so you can say that from one room, if I want to access something from the other room, I want to get permission from them. From one room, if I need to access, if I need to get some object, for example, a water bottle is there in the second room, this room. I want that bottle here in the first room. So what I have to do, I cannot directly go and take it. I have to get permission from the particular owner, and then only I can get the data here. Okay, so I will not be able to directly access, I can only able to access indirectly. For that purpose only we are introducing pointer. So whenever a memory block is allocated in the heap memory, then those memory block cannot be accessed directly here in the RAM. Then what I require a pointer. Okay, so for example, I'll just tell you one thing. Suppose if the heap memory is having 5 blocks continuously, for example, not I'll just consider that as a single block is allocated. Okay, or otherwise you can imagine 5 blocks. So one block, then after one block, what I can do, again I can go for next block. Okay, next what I can do, I can go for one more block also. Okay, one more block I can go for. So 3 blocks, and followed again by one more block, and followed again by one more block. So totally how many blocks are here? 5 blocks are there, and these 5 blocks are allocated in heap memory. Now I'll just tell you the way how to create memory in the how to allocate memory in heap. That I will tell you later. Okay, but now let us assume that the memories are allocated here in the heap. So when the memory is allocated here in the heap, you will not be able to directly access it. You will not be able to directly access these memory block here in the stack. But what you can do instead is, these are continuous memory blocks. What you can do is that you can create, for example, you can create one block here in your stack. For example, you are creating let me consider that you are creating a activation area inside this stack, and inside that activation area you are creating one block, and this block is called as address variable. What is address variable? Pointer. And this address variable, what you are going to do is you are going to take the address of this first node. Let me consider that the address is going to be 2343. Okay, the address is going to be, like, for example, let us consider that the address is going to be like 1234, and the address of this is, address of this is 1234. Okay, here 1234. So if the address of the first block is 1234, what I need to do, I need to take that address. And what I have to do, I have to store it inside this variable 1234. So taking the address of the very first block and storing it in the pointer address variable inside the stack. Okay, and now this block will be having one name. Okay, some name, for example, like A or B or P, some name will be given. So now what you can do is, using the address of this block, now you will be able to access this one, this block. All these blocks you will be able to access using this pointer. I'll tell you how this consequent blocks can be accessed. But whenever a memory is allocated here, whenever a memory is allocated in the heap, then I cannot access it directly. Then I will be requiring a pointer, and that pointer will store the address of the base block, first block, and using this address we will be able to access this entire memory block here in the heap. Okay, so what I can clearly state is that a program can access the code section and stack section directly, but it cannot access the heap section, which is external to the RAM. So we need pointers to access the heap memory. So what I can tell you is clearly, I'll just write this statement very clearly, very important statement, right? So I can say that a program can access code section and stack section directly, but the program cannot access the heap memory which is external to the RAM, which is external actually. Okay, so in that place, what we require in that place, we need pointers to access heap. We need pointers to access heap. Okay, fine. So now I'll just tell you for one example whenever this pointer is required. For example, I'll tell you one thing. We'll just come to the case of printer. For example, if a printer is there, which is connected to your system, your laptop, for example, or otherwise, what I will just consider is that I have connected, for example, I have connected my mobile USB. Okay, I have connected my mobile USB here. So what will happen is automatically your mobile is connected to the system, right? But your mobile is some external device to your system. Am I right or wrong? Because your mobile is a external, whatever is internal to your system, your hard disk, your RAM, these are all internal to your system. But according to a system, a mobile is an external device which you are connecting it externally, right? How these two devices are connected? How my mobile and this is connected? For example, I can show you the folder also. I'll just show you the folder. See, okay, the folder is not here. Okay, 1 minute. I think now, yes, can you able to see here? A device is here. Okay, a device is here, connected here. So if I just double click on it, it is going to just open. For example, it will be showing, yeah, it is showing card, phone. For example, if I'm just clicking on card, you'll be able to see many folders in it, right? All this data, okay, all this data are there inside my phone. All this data, all these memory blocks are there in my phone. How will I be able to access those memory, those data which is in my mobile? Because my mobile is an external device, so I cannot able to directly access this. So what I require is actually I require a pointer. So what happens is that here a device is shown here, right? This is a pointer. So a pointer is created in the RAM. The pointer is created in the RAM of our system, and that pointer is holding the base address of our mobile device. And using that address only, using that pointer only, what is happening? The entire data can be accessed and shown here. The entire data can be accessed and shown here. So whenever external resource, okay, whenever external resource need to be accessed, then what we require is always we require pointers. Okay, for example, we can take printer. If you take printer, a printer is an external device. What happens whenever you want to connect an external device, printer, to your system? People will give you driver, a software which is given by that manufacturer. What that device will be having, what that software will be having, that driver, that software will be having a code. That code will create a pointer and store, and it will receive the address from the printer, and it will store that address in the pointer which is created in your system RAM, which is done by that particular driver or software. That is why without software, without a manufacturer software, no printer can be able to be connected, because that software is having the code. In that code, a pointer is created. Using that code, a pointer is created, and inside that pointer, what is happening? The connection address of the printer is stored. So whenever I want to connect an external device to our system, then we require a pointer. That is what I'm trying to say. Whenever this heap memory is there, if I want to access the heap memory, then I want a pointer in the stack. This pointer means it is capable of storing the address of the memory block. For that reason only we want pointer. So just see, so much thing I have spoken now. So much thing I have spoken. These things you have to just understand. Okay, so why you require pointer is very important thing. And now I'll just tell you one place where you require your pointer is for accessing your heap memory. For accessing your heap memory, you want your pointer. And the next one is to accessing external resource. For example, now I told you a few example, right? Like mobile device, like printer. So if whenever you want to connect a external device, then we need to go with pointers. External device, or can be generally called as external resources. And then followed by parameter passing, that we have still not seen, that we will see parameter passing. Whereas parameter passing means it is related to function. Still now we have not seen function. To see function only, all these things we are seeing before itself. Okay, fine. So now what I will do is better, I'll just go to the editor and I'll give you few demo of pointers, how pointers have to be declared and how it has to be used. Okay, so I will just first of all take a data variable. Integer n is a data variable. For example, data variable, and this n can be stored with any values like 10 or 20. Any values can be stored. So this is called as data variable. And followed by this, I'll just take int star p. Whereas whenever the star is written in front of the point, in front of a variable, then that variable is called as address variable, or otherwise called as pointer. And n is called as data variable because nothing is preceding my variable, and here star symbol is preceding my variable name. So automatically p becomes address variable, or also called as pointer. Okay, now so this is the declaration part of a pointer. This is how you declare a pointer. So you are going to declare a pointer. So this is the declaration point. Okay, see, if I want to store the address, of integer pointer, then I will be declaring a integer. If I want to store the address of an integer variable, then I will be declaring an integer pointer. Suppose if this is a character variable, then I could have taken character pointer. Why it is I'm taking integer means integer pointer, character means character pointer? Because using this pointer variable, I will be indirectly accessing this block. So if I need to indirectly access this block, then both these blocks should have the same memory. So this pointer also should be capable of accessing 4 byte or 2 byte, if whatever the byte of integer is. So always we prefer both the data type of the pointer as well as the data variable, pointer variable and data variable, to be always the same data type we need to use. Now this is the declaration part. Let me go for the initialization part. While initialization, what you need to do is, no need of again using star. Again you can give p is equal to what is the usage of pointer? You can store the address of a data variable. So how to get the address of a data variable? There is a operator called ampersand, which you use in scanf. I have shown you already. This ampersand, what it will do is, it will find the address of the corresponding variable. I told you variable is the name given to a memory block. So when n is the name given to a memory block, then this ampersand will reveal what memory block is given the name called n. So ampersand n will give you the address of the block called n, variable n, and that address will be stored in p. So what will happen, I have already shown you here in the Excel sheet. Okay, already I have shown you in the Excel sheet here. For example, you have two blocks called, for example, this block is called as p and this block is called as x, and x is now stored with a value called 10. And now the address of this x variable is this one, and this is stored inside my p. This is what happens when you give the statement. This is declaration, and this part is called as initialization. And these two parts can be merged also. How this can be merged? Instead of giving both these things in a separate line, instead of giving both these lines in a separate line, you can give it here itself. Int star p is equal to ampersand n. So the declaration and initialization can both occur in the same line itself. Initialization. Okay, so declaration can occur separately and initialization can occur in a new line, or otherwise both the declaration as well as the initialization can occur in the same line also. Now what I will do is I'll just print the value of a and value of p first of all. Okay, percentage d. I'll just print the value of n and followed by I will also print the value of p. I'll just print both these values and we will check what is the value of n, what is the value of p. We will just print and check. We'll just print and we will check. So executing this, I'm getting 10. And what is this? This is a very big number. This is the address of a number. I told you always the address is hexadecimal, right? So we will just give x. Percentage x means it is having the capacity format specifier to print a hexadecimal number. So we will just again execute it. So what it is giving me 62FE14, which is the hexadecimal address of this n, because you are storing the address of n only inside p, right? So now what p will be having? P will be having the hexadecimal address. That hexadecimal address is the address of this data variable. So that address is only printed here. So here the address of p is not printed. Here the value of p is printed. What is the value of p? Value of p is the address of this variable called n, that is printed. So to make you understand, I will just print the address of n. I'll just print the address of n and then the value of p. Okay, so when I just print, I'll just make both these things are hexadecimal representation. Now I'll just explain and now I'll just print it. Can you able to see both are printing the same value, because the address of n only we are storing in the variable called p, pointer variable. So both will be having same. So the address of the first variable and the address of the value of the second variable are same. Address of first and the value of the second variable are same. Okay, so now if I just simply give p, what it is referring to, it is referring to the value which is inside this p block, which is the address of another data variable. Suppose using this address, if I need to access this value called 10, then dereferencing I need to do. So if I just say p is called as referring to the value. Suppose if I want to dereference, what is dereferencing? Dereferencing means from here, using the address, if I access this value 10, this is dereference. So how dereferencing has to take place? You have to place a star in front of the variable. So when p is happening, it refers to the value. When if you give star in front, automatically it will go to this memory block and it will retrieve the data of this corresponding memory block. So accessing the value of an address variable is called as referencing, and accessing the value of the corresponding memory block, accessing the value of the corresponding memory block is called as dereferencing. So p will refer to referencing and star p will tell you that you're doing a dereferencing. Okay, so now what we can do is, instead of printing p, let us print star p. Let us print star p and check what it is printing. Okay, just I'll execute and I'll just print. Now if you see, it is printing a, because why it is printing a means you are giving percentage x as a format specifier. What is the corresponding representation, hexadecimal representation of 10? A is the corresponding representation of 10, that is why. So let me change it to percentage d. Okay, percentage d. So now just let me print it. Yes, it is printing 10. So if I give p, what is happening? The address of the variable called n is printed, because that is what stored in p. Suppose if I give star p, what is happening? The value of the block is given. So referencing and dereferencing. So p means this value, star p means it goes to this place and it searches for the memory block, it goes there and it takes a value which is there inside. Okay, so referencing is pointing this p to this, p is referring to this address, and star p, your flow is going to this block. This is what you see. So far what we have seen, if you see, we started with Pascal triangle and then we get into pointer and we see why pointer is required, how it can be declared, how to initialize it, and also dereferencing also we have seen so far. Okay, so now in the next lecture what we will do is, we will continue this. We will continue how to do memory allocation, dynamic memory allocation. Okay, so we will see all these things in the next session. So for this session, what you have to be very clear about is, why pointer is required, how to declare a pointer, and how to initialize a pointer. These three topics you have to be very clear about. Okay, right? Double pointer, all the other things, detailed things about pointer, that we will see later. Now we are seeing pointer to start functions. Okay, now we are seeing pointers just to start functions. So we'll be seeing about pointers later in a separate session. See, array will be taught to you in a separate session very deeply. Then coming to structure also will be taken care of in a separate session. Similarly, pointer also. But I'm teaching you only the basics of array, basics of structure, basics of pointer, in order to teach you functions. Okay, so before coming into function, we need to know all these basic things. Okay, fine. So now this is it for the session. The next session, for example, this session, I think it is done for almost totally 45 minutes. So it means around 50 minutes we have the session for. So we are starting the session by 6 o'clock, and now the time will be 6:50. Now the time is around 6:50. So what we will do is, we will again start the next session by 7 o'clock, and we will be having one more half-an-hour session from 7 o'clock to 7:30. Okay, so hope to see you in the next session. So this is it for the session. Thank you.